So moving on, what's next? We've done silver, we've done lead, we've done the group 2s. Now let's go to the copper. Not much to do with the copper really, just one very important addition and a couple just for the fun of it. Okay, so anyway, you take copper 2 ions. Now we took copper chloride for this. We could have taken copper sulfate, whichever way we do it. Copper, when it is copper 2+ when it's in water, generally, unless there's something really weird which you're not going to encounter very often, it's an octahedral copper if there's nothing else floating around in there. All 6 of the ligands are water ligands, and so copper 2+ is this lovely pale blue color. Now if I take that pretty blue copper 2+ and I add in some potassium iodide to that, then it looks like this rather disgusting mess right there. Okay, if I let that settle out, what you see is that there is a white precipitate in there that separates out and a brown solution. So this is what happens right after I added the potassium iodide to the copper 2+ solution. Let it sit for a while. I think this one actually sat for 3 hours, not because it had to sit for 3 hours, but because I kind of had to go off and do something else. But anyway, you get this white precipitate with the brown solution. Okay, and that is really, really significant. Anytime you see on your A-level brown solution, white precipitate, and there's a chance that it's formed by copper 2+ mixing with iodide, you know that's what's happened. What has actually happened is a nice redox reaction. Okay, the copper 2+ gets reduced to copper 1+. Okay, and if it's getting reduced, in other words, it's gained an electron, something else has been oxidized and lost an electron. Well, the other species that's in there is the iodide. If an iodide loses an electron, then it turns to an I atom, 2 of which come together to make an iodine molecule. So the redox reaction is copper 2+ going to copper 1+. As far as the reduction, the oxidation is 2I- going to I2, but then there's some other iodides floating around that have not been oxidized that can hang out with the copper plus. Copper 2+ iodide is soluble. Copper 1+ iodide is insoluble. So the white precipitate is the copper 1+ iodide, okay, that's formed from the reduction of copper 2+ to copper 1+. The brown solution is the iodine that is formed by the oxidation of the iodides. Okay, very, very important thing that you need to recognize and memorize. Now, continuing on, just because we had fun, take copper 2+ and react it up with sodium carbonate, and we get a blue precipitate. All carbonates are insoluble. We saw that they were insoluble for the group 2 cations. The only soluble carbonates are those of the alkali metals, so lithium carbonate, sodium carbonate, potassium carbonate, and so on, and ammonium carbonate. Okay, other than that, anytime you have carbonate with any other cation other than alkali metals or ammonium, you can expect to precipitate. As this is a copper 2+ precipitate, the default color of copper 2+ is blue. Finally, copper 2+ with sodium hydroxide, you get a nice pale blue precipitate there that is simply copper 2 hydroxide. So copper 2+ plus 2 hydroxides goes to copper hydroxide as a precipitate. If I add in more hydroxide, no change. So in other words, copper 2+ ions are not amphoteric. Big thing to remember, copper 2+ is the reaction with iodide that leads to the redox process, and so you end up with a brown solution and a white precipitate.